Okay, so today we're going to talk about, they're called rational expressions. So the word rational, anything that's a rational number is basically a fraction. Anything that can be written as a fraction is a rational number or a rational expression, okay? So the word rational means it can be written as a fraction, okay? So we're going to reduce today. We're going to reduce. We're going to multiply. And we're going to divide. Okay? And we're going to follow the rules that we learned in 6th grade, hopefully. Right? Alright, so first of all, example 1 is just a fraction, and it just needs to be reduced, alright? So, what I'm going to do is reduce the answer to 3/6 is 1/2. Everybody agree with that? Agree with 1/2? And for these x's, we'll cancel out 4 of these x's, right? 4 of these, we'll cancel 4 of these. And if this is confusing, and if you never learned this in Algebra 1, 1, 2, 3, 4, 5, 6, 7. I want to show this just briefly. 1, 2, 3, 4. And I hopefully don't have to show this again. But x to the 7 is like x times x, like 7 of these, right? And x to the 4th is like 4 of these, right? Okay, and I'm not going to show this, but just this one time, okay? So then that x cancels that x cancels that. X over x is 1, but it cancels. X over x is 1. And what are we left with? 3 of them, or x to the 3rd, but it's on the top. You agree with that? X to the 3rd. Now, that would be a silly way to do that all the time, correct? An easier way to do it is just say, okay, 4 of these, cancel with 4 of these, or you subtract exponents, okay? Capiche? It's reduced. We've just reduced, okay? Number 2 is just a bigger reduction. So, fraction bar. 6 over 3 is 2 over 1. I do not need the 1, but I'm going to put there anyway. Okay, don't need this 1 because it's on the bottom. It's in the denominator. 3 of these x's cancel with 3 of these x's, which leaves 4 of the x's left, but on the bottom, right? Annalyn's going to put her phone away. Yep. 3 of these y's cancel with 3 of these y's, which leaves 2 of the y's on the top or the numerator. That's it. Not hard, is it? That's not that hard, right? Okay. All right, now 3. There are 2 ways to do this, but we are not going to be so silly as just to multiply, because it can be done. If you want to go this times this, and if I want to write that as, and I will not do this, I'm not going to do this way. If I want to make this a 30x6 y squared over a 24x5 y2, I'm not going to do that. It can be done that way, yes. And then cancel, cancel, cancel. I'm going to cross reduce first. Where'd my sponge go? It's in the board. Here it is. I'm not going to do it this way. If you want to do it this way, multiply straight across, you can. Katie and I are going to reduce, aren't we? So let's check it out. What do we got? Well, I can cross reduce a 2 and an 8 and make it a 1 and a 4, right? I can cross reduce a 3 and a 15 and make it a 1 and a 5, right? These two x squareds should cancel each other, right? X squared cancels x squared. This y2 with this y5 should cancel. 2 of these with 2 of these should give me a y3 when I cancel 2 of those with 2 of those. x3, x4, 3 of these should cancel with 3 of these. Hold on, Avi, and I'm going to take your question, which makes 3 of these cancel 3 of these, which just makes an x on top. Avi, question real quick, yes?
Wait.
Now it's hard to see, but I can put it back up again.
So I don't even know how to say this quickly. Yeah, why did he cross reduce the
Right.
15?
So when we multiply it out, think about this. All of this really is on the top, and all of this really will be on the bottom, right? When we multiply it out. So if this is on the top, why not let the 3 divide into it? Just reduces it, right?
Oh, I got it. Yeah.
Right? Does that make sense? So now I've cross-reduced. I've reduced my 15 and my 3, and I've reduced my 2 and my 4, and I've reduced my x's, because I can put them all together, right? But why not reduce them before we multiply? Because it makes it easier, right? So what do I have? I've got a 5x y to the third over a 4. Yeah, Jacob.
Sorry, how do you like cross reduce the exponents?
Right, let me go ahead and slide this back over, okay? So let me just for a second rearrange some things, okay? Let's take this x to the 4 over here, right? And let's take this other x2 here. I'm just doing the x's so you can see it, okay? Let's put this x2, and I can, as long as it's on the bottom, right? Let me put this x2 right here. Let's put this x3 right here, okay? And then from here, you can see that cancels, right? Yeah, and then this is like x times x times x, x times x times x times x. So 3 of these would cancel 3 of these, right? So 3 of these cancel 3 of these, one would be left over.
So you just did the cross reduce thing for the leading coefficients, and then you just do the normal.
Right, just do the normal canceling x's and cancel y's, right? So that when I wind up doing all my canceling, I'm left with 5x y cubed. 1 times 4 is 4. Okay, let me do another one, okay? So number 4 really is the same stuff except it's divide, so we have to flip the second fraction first, okay? So I'm going to have a 4x cubed over 9y squared times 9y to the 5th over 16, okay? Now, Jacob, here's a great example of the same kind of thing, right? So what I want to do is this 9 is on top and this 9 is on the bottom, right? Even though they're not directly above each other, it's still 9 over 9. So let's cancel that to make it 1 over 1. Because if I reduce 9 ninths, it reduces to 1 over 1, right? And the 4 and the 16, even though they're not right above each other, 4 is still on top and the 16 is on the bottom. So let's reduce 4 sixteenths, reduce them both by 4, and I'll have a 1 and a 4, okay? Now with the x's, there's 2 x's here, 3. 2 of these x's will cancel out 2 of these x's, right? So I'd be left with just an x on the top, because 2 of these cancel 2 of these, left with x, right? And the y to the 5th, there's nothing to reduce the y to the 5th left. So then after all this mess, what's left over? I've got a 1x and a y to the 5th, right? So I've got an x and a y to the 5th. And I can put the 1 in if I want to. I don't need the 1, but I'll put it there anyway. Over, what's left on the bottom? Just a 4. Okay? Now example 5 is different. Okay, and I got to say this 5 times. I think that's irritating enough. Okay, because of the plus and minus, it needs to be factored. Do not cancel x squared with x squared. You can if they're multiplied. Do not cancel x squared plus x squared. Let me show you a simple example. If I have 7 plus 3 divided by 7 minus 5, is the answer 3 over negative 5? It's not, is it? Right? The answer is 10 over 2 or 5, right? You guys agree you can't cancel the x's? Because you need everything on top to be divided by everything on the bottom. So the way we do it is we're going to factor, okay? So let's factor. X and x. So again, like I said, if you can't factor, you are in big trouble in this lesson, right? I'm going to go a negative 3 and a positive 1, because that will make my negative 3 and my negative 2. Okay, you all right with my factoring there? Now, on the bottom, or the denominator, I'm going to go x plus 4, x plus 1, right? Now, because they are multiplied, you can cancel. You can cancel. What am I going to cancel? My x plus 1 with my x plus 1. And my answer is my x minus 3 over my x plus 4. Okay? There is my answer. Okay? What do you think? These aren't so bad. If you can factor, you're going to be good to go. Okay? So example 6. All right? So here, this one's going to take 2 steps. And I'm going to go through it slowly. On the top, or the numerator, I'm going to factor out an x. That'll leave me a 2 minus x, okay?
What?
So I took out an x. They got an x in common, so I took out the x, right? This one I'm going to factor into an x minus 2, x plus 1, okay? These don't cancel yet because they're not exactly the same. They got to be exactly the same. This is a 2 minus x, not a x minus 2. But what I want to do is if I take out its negative, if I take out a negative 1, it'll make that a positive x and that a negative 2. So I'm going to take out a negative 1. So I'm going to go ahead and make a negative 1x, and that'll turn this around. If I take out its negative, it makes it a... Well, great question, Tammy. I want these two to be the same. So if I can make this negative x into a positive x, so if I factor out its negative, so I'm just factoring out its negative. If I factor out its negative, it becomes a positive x. This is a positive 2, but if I factor out its negative, it changes it from a positive to a negative, okay? Now let's go backwards. Let's check it out. That would make a negative x squared, yep. And that'd make a, that would make a negative x squared, yep. And that'd make a positive 2x, yep. Okay, and the reason I want to do this is because now I can cancel my x minus 2 with my x minus 2. They have to be the same. They have to be the same to cancel, okay? What's left over? Well, let's see it. I have a negative 1x over an x plus 1. Okay? These are not easy. I warned you. This is the hard stuff. Wait till we start to add and subtract and we need a common denominator. That's Monday. That's Monday. When you're more awake, right? Okay, let's take a look at number...
Wait, more awake on Monday? I don't know.
We'll see. Okay, now let's take a look at example 7. Example 7, what we're going to do is factor. Okay, so we have two fractions. So if we multiply, we could multiply straight across. What a pain, right? That times that, that times that. But what if we could factor and maybe cancel? So on top, I'm going to leave it as an x plus 2 because you can't factor an x plus 2 over, right? Over, take out a common 3, and I'll have an x plus 4. Okay, well that doesn't do me any good, but maybe on the other side I'll get a little help. X plus 4 can't factor, but that's okay. It's going to cancel, isn't it? Over, this factors into an x plus 2, x minus 2. Okay? How am I doing? Okay, cancel, cancel. This is the fun part. When you finally get here, I call it the fun part because cancel, 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 right? And what are we left with? Well, nothing on top, but you have to have something on top. And not only that, when you divide something by itself, you always get 1, right? You divide something by itself, you always get 1. So 1 on the top over 3 times an x minus 2, okay? All right? Now, remember Cookie Monster? You guys remember Cookie Monster? Okay, so Cookie Monster is going to say x cannot equal 2 right here. X cannot equal 2, because if x is 2, we would divide by 0. In fact, Cookie Monster would get so serious to say if you leave it in this form, it can't equal negative 4, and it can't equal negative 2 also, right? And we're going to talk about this more specifically, but you can't divide by 0. Okay? Cookie Monster would say right here, x cannot equal negative 1, right? Agree with that? And if Cookie Monster wanted to get really serious, he'd say, well, x can't be 2, and x can't be negative 1 also. And we're going to talk about that more, okay? If Cookie Monster said, hey, don't divide by 0, he'd say x cannot equal negative 4. But at the same time, x cannot equal negative 1. If we didn't cancel it out, we'd also say x cannot equal negative 1. Can't divide by 0, right? Cookie Monster's pretty happy here, unless you go to the original, and Cookie would say, don't let x equal 0, y equals 0, okay? He's pretty happy here, because there's no 0 on the bottom, right? But if you wanted to get picky, he'd say, don't let x equal 0 and y equal 0, okay? He'd say for sure x cannot equal 0, right? Because then you'd divide by 0, right? If you wanted to get picky, he'd go into y better not equal 0 too. And we're going to get picky later, not today. And then up here, Cookie Monster would be happy with this unless we went back to the original problem. The original problem would be don't let x equal 0 because you can't divide by 0. Okay, it makes sense? We've talked about this before. Don't let the bottom or the denominator equal 0. It's undefined. Okay, so now this one takes a little bit of room. I should have made room for it, but I'm going to do number 8 here on a separate sheet of paper because it just doesn't quite fit. So number 8, can you see that? Yeah, I'm going to rewrite it as x to the 5th minus 4x cubed over x squared minus x minus 2. This is the hard one, but I don't mind doing a hard problem. Okay, this is the only hard one. X to the 5th minus x to the 4th minus 2x cubed. We need some hard problems every now and then because it keeps us sharp, makes us think. Okay, all right, there we go. Now, you're probably going to do this, I expect you to. When you see a division problem, I don't even write the original problem. I automatically just flip this. Does that make sense? This first step for me was a waste of my time because I already know I'm going to flip this. So if I were doing this problem out of my book, if this part of my homework, I would have started just like this. I'm going to flip it. Would have gone straight to times, right? And I'd go my x squared minus 1 over my x to the 5th minus x to the 4th minus 2x cubed. Okay? All right, you guys agree with that? I mean, if you're doing your homework, you see division, you know you're going to have to rewrite it and flip it. Why not just do it right off the bat, okay? Does that make sense? Okay, save yourself one step. Okay, we need to factor. Okay, we need a factor. Okay, so in the first example, I'm going to common factor out an x to the 3rd. See the x to the 3rd they have in common? Okay, x to the 3rd. So then I'm going to have an answer of x squared minus 4. This will factor into an x minus 2, x plus 1. How am I doing?
So we can factor the top one.
Yes, you're and I knew you'd see that, Claire. Thank you. Yep. I'm going to factor. Claire said, let's factor this again. You guys okay with that? You guys mind if we factor this one again? I agree with Claire. We can factor that one into just simply x plus 2, x minus 2. We're going to save ourselves some time. You guys agree with Claire? May as well factor that one again. Times, this is an x plus 1, x minus 1 over, okay, let's common factor out an x cubed, okay, so common factor out an x cubed, we'd be left with x squared minus 1x minus 2, and then Claire's going to say, Mr. Davies, what are you going to say, Claire? Let's factor this one, right, because this one would also factor into x minus 2, x plus 1. Okay, now we finally get to what I consider the fun part, because we get to cancel. If we factored correctly, then anything on the top, no matter where it's at, can cancel with anything on the bottom, because we can rearrange the order, right? So let's not rearrange the order, and let's just cancel, okay? So for instance, that would cancel with that, right? X cubed would cancel with x cubed, right? What else do I have? I see an x minus 2 with an x minus 2.
X plus 1.
I think that's it. I think that's it. So what's left over? What's left?
What about the x minus 2 and the x plus 1? There.
With what?
Don't you cross those out as well?
It's got something's got to be on the top.
Yeah, there's nothing else.
Nothing else on the top. See, there's an x minus 2 here. Yeah, see, it's got it. So what's left? Let's write out what we have, Katie. You'll see it. On top, I'd have an x plus 2, x minus 1. On the bottom, or the denominator, I'd have an x minus 2, x plus 1. And they're different, aren't they? And that would be my answer. It's not a very nice answer, but it's at least a lot simpler than what we started with, right? Okay. Okay, I got 2 more problems left, and the next 2 problems are easy. We just did the hard one, okay? Number 8, that's the hard one. You guys agree? Pretty intense. Okay, so let's take a look at, okay, solve for x. Okay, before we do any of these solve for x, so we got to get x equals. So before we do anything, we got to consult Cookie Monster, okay? So we're looking for, before we do anything, undefined values, okay? I'm going to circle that. Before we do anything, let's look for undefined values, okay? So before I even start, I know that x cannot equal negative 3, okay? Because if x were negative 3, negative 3 plus 3 is 0 divided by 0. So if we get an answer of negative 3, we're going to throw it away. You guys agree with that? Okay, so step 1, let's factor, okay? Let's factor because we might get some canceling, okay? We're going to have an x plus 3, x minus 3 over a x plus 3 equals 7, okay? Cancel, right? X minus 3 equals 7. Easy squeezy, right? Plus 3 plus 3x equals 10. Whew. We don't have to make Cookie Monster mad, do we? We're good. X is 10. It's not negative 3. If x were negative 3, we'd have to throw it away. Okay? Can't make Cookie Monster sad. Okay, then, example 9. How am I doing? So before I even start, I got to make sure I keep Cookie Monster happy. All right? What's my undefined value? X cannot equal what? 1. Everybody agree with 1? Positive 1 right here. Positive 1. 1 minus 1 would be 0, right? Can't divide by 0. Bad news. So, let's see if we can factor, okay? If I go x plus 4x minus 1 over x minus 1 equals 5, right? Cancel, cancel, right? Right? There you go. Sorry, Renee. There you go. That's easier, see? Am I going too fast? Am I okay? Okay. And then I've got x plus 4 equals 5, right?
What? You get x equals 1.
Very good, Claire. Minus 4 minus 4x equals 1. Cookie Monster's really sad.
Why? Because x cannot equal 1.
Let's go back to the original. If x equals 1, what's going to happen?
Undefined.
We would divide by 0, undefined. So what's our answer? There's none.
Undefined.
There are no solutions.
Can't see
That
it.
problem.
No solutions. Okay. How's that? Not bad. But before you do any